Hi guys, this is Mr. Richard. We are on question 4 now, right? Question 4 consists of 18 marks, right? In our previous video, we saw how we can get that 22 marks. So now we're working on 18 marks, which is question 4. That's a lot of marks, guys. You can't afford to lose such. Well, if you're new to this channel, what are you waiting for? Don't forget to subscribe. Let's go. 1, 2, 3. Subscribe. Thank you. Let's grow this community. Remember, guys, our goal is to reach 1K so that we grow this channel to a big channel and so that we improve the content. And don't forget to comment, guys. Your comment. We value your comments and your like. Don't forget to like this video and don't forget to share. Right, so let's start with the first question there. It says prove that sine theta minus cosine theta divided by cos theta subtracted by 1 or separated by, open the bracket, 1 minus sine squared theta, which is an identity then equated to tan theta. So the easiest side that we can work with is the left hand side. Right hand side is quite tedious because when you change it, it will be sine all over cos. So that is quite tedious to work with such. So I prefer that we chose left hand side. Let's choose left hand side so that we are able to find the solution. Let's put this into practice. Well, this was a 4-mark question. So what are we going to do here? Oh, remember when you're working with identities, remember we are required to prove that the left-hand side is equal to the right-hand side. We use this technique, innocent until proven guilty. When you want to caught or when you want to catch the criminal, you must have substantial evidence. So that we are able to arrest the criminal. Similar approach works here. So let's check first. What do we have at the numerator? We have one type of factorization which is called factorizing by a highest common factor. So we are going to factor out what is common here at the numerator. It's sine theta. So we are going to say sine theta. We'll be left with what here? 1. And what? Okay. Minus cos theta. We'll be left with that because sine times 1 is sine theta and sine times negative cos theta, it's negative cos sine. Right, we are on, right? Yes, we are doing it correctly. So let's work with the denominator now. Cos theta. Oh, we have an identity. Remember that this identity comes from sine squared plus cos squared theta, which is equals to 1. So what we can do, we can make cos the subject in this case. We can make cos squared theta is equals to 1 minus sine squared theta. So meaning that where there is when we see 1 minus sine squared theta, we'll replace it with cos squared theta, right? So in this case, we are going to have cos squared theta. The identity of 1 minus sine squared, it's cos squared theta, right? So let's continue again. We have 1 minus cos theta there. We have a common factor again here. What is common? It's cos. Then let's factor out cos. We're left with 1 here minus cos theta, right? Cos times 1 is cos and cos times negative cos is negative cos squared theta. So common brackets, they cancel each other then. This and this go. Then we're left with sine all over cos, which will be tan theta. Therefore, the left hand side is equal to the right hand side. So that's how you can prove 4.1. Let's go to 4.2. Right, at 4.2, guys, we are required to determine the general solution of 2 sine cos subtracted by cos squared x is equals to 0. How many marks? 6 marks. Oh, that's a lot of marks. You can't afford to lose that. So First thing we need to ask ourselves, what type of general solution this? This is a type of general solution that requires factorization. Why I say so? Because we can see that cos x is common. So let's put this into practice. Right, since we are given 2 sine cos x subtracted by cos squared equated to 0. First thing first, I did emphasize that we need to take out the common factor there, which is cos x. Then we are left with 2 sine x there. Okay, minus, to get to cos squared x, we need cos x here. So in this case, equated to 0. We will then, since this is a type of equation where we need to equate, yes, this is, we are going to equate everything here. Cos x, okay, cos x is equals to 0. 2 sine x minus cos x is equal to 0. Right, so now it's time that we find the reference angle, RA. Then what is the reference angle of cos second function of 0? That will be 90. It's 90. So we are going to have 90 degrees. Let's refix this into standard form. So it's going to be 2 sine x and cos x. Remember, when you're having such type of general solution, divide both sides by cos to form a quotient identity, which will be tan. So this will be 2 tan x, which will be equated to 1. Divide both sides by 2. Tan x will be half. So to find the reference angle, we are going to say RA. Second function of half, use your calculator there. Second function of half, it's 20, that will be 26,565 and blah blah blah. Don't round off your answer. You'll round off your answer in your final, you round off your final answers there, right? So in this case we're having 90 as a reference angle, okay, plus k times 360 there, right? Okay, 90 plus k times 360. Or correct to 2 deciplaces. Correct to 2 deciplaces. What will be this? Okay. This will be 26,57. 26,57. Since it's tan, remember the period of time, that will be 180. So don't forget to write k. It's an element of integers, guys. You don't have to forget that, to write k. It's an element of integers. Another solution here, we may think, where is cos positive? Cos is positive on, remember the CAS diagram, all students take coffee on the 4th quadrant. So we are going to say 360 subtracted by 90 plus k times 360 there. Okay, so all right, 360 subtracted by 90, that is 270. 270, okay, 270 plus k times 360. Okay, right, 270 plus k times 360. Another solution that we can think of, we can look at where tan is positive. It's positive on the 3rd quadrant, so we can add that 26,56 plus 180 plus k. That will be the solution. So that's it with 4.2. Now let's go to 4.3. Yes, we are at 4.3. At 4.3, solve for alpha if 2 root sine alpha is equals to 1, where alpha it's an element of 0 and 360. We need to follow the restriction. So our answers must be between 0 and 360, right? So let's put this into practice. Yes, guys. From here, what you could do is round off to 2 deciplaces. Then you will add by the period, which is 360. So from there, you ask yourself, remember, we follow the restriction. Our values should be between 0 and 360. If we place -3, it will be huge. If we place -2, it will be huge. Place 1, it will be huge. But if place 0, that will get 14,48. So let's think of another solution. Where is sign positive? It's on the second quadrant. Just say 180 subtracted by 14,48. That will be 165. So another solution here will be 165,52. So that's how you can get the solution here. That's how you can solve that 4.3. Now we are going to our last question, which is 4.4. Yes, at 4.4, if x and y are acute angles such that tan x plus y divided by 2 is equals to y and cos x minus y is equals to √3 all over 2. Find the values of x and y. This reminds us of semi-tenuous equations. So in this case, we have to have two equations, right? Let's put this into practice. Yes, first thing first, let's make this equation 1. We will say x plus y divided by 2. Then let's find the reference angle of tan. Second function, tan 1, that will be 45. It's a special angle, isn't it? So 45 degrees. So what can we do here? We need to make y or x the subject of the formula. So we can multiply both sides by 2, isn't it? We can multiply both sides by 2. This and this, they cancel. So we are left with x plus y is equals to 45 times 2, that will be 90, right? So let's make y the subject. So we are going to have 90 minus x. So we name this equation 1, right? So let's work with this again here. We have x minus 1. So √3 all over 2, it's a special angle. Let's see, cos divided by √3 all over 2. Okay. Oh, it's a second function. Second function, √3 all over, okay, sorry for that, divided by 2. Okay, that's 30. So we're having 30 here. So this, we can name this equation 2, isn't it? So since we know that y is equals to 90 minus x, so substitute equation 1 into equation 2, right? So from here, where we see y, we shall put 90 minus x. So in this case, we are going to have x 90, right? Okay, let me just substitute 90 minus x, so equate it to 30, right? So in this case, we're going to negative, we'll multiply everything there. That will be negative 90 plus x equated to 30. Then x plus x, that will be 2x subtracted by 90 equated to 30. Then 90 plus 30 there, 90 plus 30, that is 120. So we are going to have 120. Divide both sides, that will be by 2, that will be 60, because that will be 60, not 20. That will be 60. Yes. Okay, that will be 60. So for the here, it's 60, guys. Here to check or to make a confirmation is to you go back to the original equation there. Let's take, for instance, tan. Remember that our, we are not done. We already get x only. So to get y, what are we going to do? We are going to say 90 subtracted by 60. So what is 90 subtracted by 60? That's 30. So we are going to have 30. So to prove this, we can just say tan. Let's go to tan. Tan. Then where there is x, we shall put 60, since we got 60 there. Not 61, 60. 60 plus not 62. What am I doing there? That's 0 plus is it 30, ne? Yes, 30 divided by 2. 30 divided by 2 there. Okay, here's my 2. Okay. All right. That's 1. That's 1. So it's correct. So definitely y it's 30 and x is 60. Hope you find this video useful, and don't forget to subscribe and share and like. Right? See you on the next video on question 5. We love you.